All right, guys, let's knock out this test 29 review. Getting almost to the end. First problem says find derivative of a, which means we're going the limit as h approaches 0 of f of a plus h minus f of a over h. Okay, so I'm gonna start here, plugging in the a plus h, so I get a plus h over a plus h plus 1, just plugging in where the x's are. Also going to plug in the a's, a over a plus 1, all that's over h. You know what we're going to do here. When we have fractions inside a fraction, we're going to multiply the numerator and denominator by the LCD, which gives me, next step, here we go. When I do the numerator, those cancel, so I get a plus h times a plus 1. And then my second one, I get a times a plus h minus 1. All that's over h times a plus h minus 1 times a plus 1. That's a lot of a's and h's. Okay, so I got to work out the numerator here. See what happens. I'm going to do FOIL on that top part right there, getting a squared minus a plus ah minus, actually plus h. Then I'm going to distribute that negative a squared minus ah minus a. All that's over all this stuff in my denominator. Wow, okay, so here's what's about to happen. Those a squareds are gone, the ah's are gone, the a's are gone. Yes, that's supposed to be a plus a right there. Okay, so boom. And that's going to leave me with, let's see here, the limit as h goes to 0 of h in my numerator, h in my denominator, hint, hint, which is what I wanted, a plus 1, that's an h, and the h's cancel, so I'm going to end up with my last limit being the limit as h approaches 0 of 1 over a plus h plus 1 over a plus 1. I'm going to plug in my 0 right there. If I do that, I get a plus 1 and a plus 1 on the bottom, which is 1 over a plus 1 squared. There's your derivative. That's all you got to do on that one. Not too much. Okay, number 2, find the derivative at -1. I'm going to shorten, just since we just did the formula up there, I'm going to go ahead and plug in the -1. Send in the limit. Sorry about that. Limit as h goes to 0 of 2 minus 3 times -1 plus h. I'm just putting the -1 plus h for the x's, plus -1 plus h squared. And then I'm going to plug in -1 and see what I get. If I plug in -1, I get 2 plus 3 plus 1, which is 6, so I get minus 6 right there. All right, let's work on through there. Let's do the math work on the top. I'm going to distribute that 3, which gives me a positive 3 minus 3h. I'm doing square, multiply together, double square. I have a minus 6. And the good thing I'm seeing is I got 2 plus 3 plus 1, which is 6, and that's a 6. So what that leaves me with is my numerator. I have an h squared and a minus 5h. My denominator is an h. I'm going to cancel out those h's, which is going to leave me with an h minus 5. So if I plug in the 0 there, I just get -5. So there's my derivative. My derivative at -1 is -5. Number 3, find the limit. These are the infinities. So remember, once you get down to here, all right, you have a number with x on the bottom is equals 0 every time. No work on that one whatsoever. It's just 0. Number 4. Number 4 is the top. We divided every single term by the largest x as far as degree goes. So I'm going to say 4x squared divided by x squared plus 1 divided by x squared over 3x squared divided by x squared plus 2 over x squared. All right, and then I'm going to split that up into 2 pieces. And guys, I know you don't believe me, but I'm really giving you a break by just splitting up into 2 pieces instead of like 4 pieces. So on the top, the x squareds cancel, gives me a 4 plus 1 over x squared. Here, the x squareds cancel, get 3 over 2 over x squared. And remember, we're doing limit as x approaches infinity, which means a number on the top, the second term, because it's over x squared, is just 0. Same thing on the bottom. Limit of a constant is itself. X on the bottom, number on the top is 0. You get 4/3 for that limit right there. All right, let's go 5. One more of these. On 5, you're better off going ahead at the beginning and doing your FOIL method down here, getting 4x cubed minus 2x squared plus 2x minus 1. I actually went FIOL instead of FOIL to put it in the right order. So we'll take a step here. There's a lot of people talking in the hallway right now. I'm dividing everything by the biggest x, which is x cubed. So when 8x cubed over x cubed plus x over x cubed. Same thing with the denominator. 4x cubed over x cubed minus 2x squared over x cubed plus 2x over x cubed minus 1 over x cubed. And here we go. Split it up and simplify. So on the top, the x cubes cancel. I get 8 and then 1 over x squared when I simplify things. My denominator, I'm going to get the x cubes cancel as 4. I get 2 over x, 2 over x squared, and 1 over x cubed. So, hard part's over finally. And we can just go. So it gives me 8 plus 0, my numerator. Denominator 4 minus 0 plus 0 minus 0, which is 8 over 4, which is 2. There's your limit. Wow. Number 6, 2 more limit questions. Final limit as x approaches 1. So we're off the formula stuff. All right, and just old school here. This is actually a review. So I'm going to simplify the top. I'm going to say the limit as x approaches 1 of small, big, cube root, square, multiply, change the sign, square. And on my denominator, x plus 1, x minus 1. And by the way, I couldn't plug in 1 at the beginning because it makes the bottom 0. Those cancel. So I have this limit. I've got the limit of, as x approaches 1, of x squared minus x plus 1 over x minus 1. Now I can substitute that 1. I would get 1 minus 1 plus 1 in my numerator. Okay, I obviously made a mistake here. That's a typo. Let's change that x cubed on top to x cubed minus 1. Sorry about that. That makes that minus 1, which means I can cancel my minus 1s out, which makes this x plus 1 down here. So sorry about that. So plug in that 1 plus 1. So on the numerator, I get 1. The bottom, I get 2. So just get 1/2 there. Sorry about that. I will start that over, but that's a lot of stuff on this video. Sorry about that. Number 7. Also, same deal. I can't plug in -4 here, so I'm going to multiply by 4x to make those fractions go away in my numerator. So what happens then is, if I do this one, the 4's cancel. 1 times x is x. Here the x is cancel. 1 times 4 is 4. My denominator is 4x times x plus 4, which, by the way, those cancel. So I get this. I get the limit as x approaches -4 of 1 over 4x. Now I can actually plug in the -4, just do this direct substitution, get -1/16. Number 8. Number 8 is a log problem. It's got subtraction. Remember, you can't subtract logs. You got divide. So we're going to go x plus 15 over x minus 1 equals 2. There's one log, so I'm going to do that base, that power equals that. So I'm going to get x plus 15 over x minus 1 equals 3 squared, which is 9. Cross multiply, 9x minus 9 equals x plus 15. Let's move that x over, make it 8x. Let's move that 9 over, it's 24. Divide by 8 is 3. Double check before you circle. It's good. Doesn't make anything negative, so we're good. All right, number 9. It's a cube. You know what we do. The coefficients are 1, 3, 3, 1. So I'm going to do 1 cubed plus 3 times 1 squared. I is coming up. 3. 1's first power. I is second power. Then I have a minus I cubed. I forgot I was supposed to be alternating terms there. So that's a minus right there. Second mistake on the video. I'm doing great. Okay, so I got 1 minus 3i. That's going to be 3i squared and minus I cubed. Now, you're not allowed to leave any exponent on any I. I squared is really -1, which makes that 3 minus 3. Because I cubed is I squared times I, which is -1 times I, which is just -I. So that last 3 right there, it's minus, so it's really minus -I, which is plus I. So I got the 1 minus 3, -3 plus I is -2I. That was a good one. All right, number 10. Got subtraction. Subtraction means division. So if I do 192 divided by 3, that's 64. It's asking you 4 to what power 64? The third power. Number 11, use the laws to condense it. Okay, I'm going to distribute that too. So I'm gonna make it 2 log base 5x plus 4 log base 5y minus 6 log base 5z. Now the numbers in front represent the exponents, and also don't forget anything positive ends up in your numerator, anything negative ends up in your denominator. So the numerator is going to have an x squared and a y to the 4th because they're both positive. My denominator is going to have a z to the 6th because it's negative. All right, 2 more. Number 12. Solve this thing right here. So start off by going x log 7. I'm going x minus 1 log 9. I gotta distribute this other side, make it x log 9 minus 1 log 9. I need my x's together, so I'm going to pull that over. So I have x log 7 minus x log 9 equals negative log 9. Factor out the x. If I factor out the x, it's going to leave me log 7 minus log 9, which is, by the way, log 7/9, because that's what subtraction is. It's really division. So to get my answer, I'm going to take my calculator and punch in negative log 9 divided by log 7/9. We'll punch that in. I'm going to punch it in. I'm getting 0.7429. So you can check that if you need to. Number 13, last one. Log equation. It's got addition in it, which means I'm going to multiply. A lot of logs in this test. So if I multiply, I'm doing FOIL. X squared minus 2x minus 15. When I do FOIL, equals 1. And again, I got 1 log. So I'm doing the base to that power equals that. 9 to the first power is 9 equals x squared minus 15. That's what takes care of your log. I'm moving the 9 over. If I move the 9 over, that becomes a negative 24. Factor that with a negative 6 and a positive 4. So I get these two answers. I get 6 and negative 4. Check them though. If I plug negative 4 right there, it doesn't work. If I plug 6 in, it does. So 6 is it. All right. Hope that helped. That's a lot. Hope you do great tomorrow. Have a great grade. Only 2 more to go after this. That's crazy. See you then.